Hello everyone, welcome back. So today we will cover gas exchange under respiratory system. We will again break it into parts. Today I'll talk about gas exchange, tomorrow about ventilation, perfusion. So let's start with gas exchange. So what is the atmospheric pressure? The atmospheric pressure is about 760 millimeters of mercury. Now to understand things better, let's keep this as 0. So let's consider the atmospheric pressure as 0. Okay. Now, what happens when you are inhaling? Your diaphragm, which is dome shaped, becomes flattened. Your ribs move outward and upward because of the intercostal muscles. So when you are breathing in, the muscles are expanding, are stretching, and your thorax volume increases, and therefore the pressure drops. So because of inhalation or inspiration, what happens? Imagine at rest, a scenario, it is 0 and 0. But when you are inhaling, because of the respiratory muscles, the lung expands, and by Boyle's law, when the volume increases and the mass is constant, when the volume increases, the pressure drops. So the volume increases, the pressure drops. So let's assume this is -1 inside because of inhalation or inspiration. So now 0 to -1. So how will air flow? Air will flow from higher value to the lower, from more to less, and therefore air enters into the lungs. Now expiration, or when you're exhaling, the diaphragm returns back to its original position. The ribs move back, and therefore the lung volume decreases. Now, now when the lung volume decreases, what happens to the pressure? It will increase. So now during expiration, it becomes +1. So now +1 and 0. So air will move from high to low. So air will move outward. So inspiration, air is moving inward. Expiration, air is moving outside. Okay. Now let's get deeper or more microscopically. Inside we have the trachea. It's the conducting airway. It divides into primary bronchi, secondary bronchi, tertiary bronchi, terminal bronchioles. Until then, it's conducting zone. Beyond that, starting from respiratory bronchioles to the alveoli, it is the respiratory zone where actual gas exchange takes place. So now if I zoom this, you have the alveoli, and you have 10 capillaries traveling close to it. So now you have oxygen here inside the alveoli, right? And you have the pulmonary artery, and you have the capillaries, the pulmonary capillaries basically, which is the pulmonary artery, and then you have the capillaries, and then the pulmonary vein. So what happens is, in the last class I had mentioned the membrane, the alveolar epithelium, and then you have a thin protein membrane, and then you have the capillary membrane. It is very thin. It is made up of simple squamous epithelium, so that gas, oxygen and carbon dioxide can easily diffuse. The diffusing capacity of carbon dioxide is more than oxygen. Now what happens? The pulmonary veins and the pulmonary artery. So you have the pulmonary artery. Let's start with the pulmonary artery. We all know pulmonary artery is the only artery after birth which carries deoxygenated blood. So here in the pulmonary artery, the partial pressure of the carbon dioxide is more and the partial pressure of oxygen is less. Now when you breathe in, you have more oxygen here in the alveoli, and you have less oxygen in the pulmonary artery. So oxygen will move from more to less, and carbon dioxide will return into the alveoli, which you will breathe out. Oxygen has entered the pulmonary capillaries, and via the pulmonary veins it will return to the left side of the heart, and then it will be pumped to the different parts of the body so that it reaches the tissues. I'll repeat once again. So you have the alveoli, you have the pulmonary capillaries. The epithelium is alveolar epithelium, and then you have the basement membrane, a protein membrane, and then you have the capillary membrane. This is very thin, which allows easy diffusion of gases. You breathe in, you have more oxygen in the alveoli, right? And the pulmonary artery has more carbon dioxide and less of oxygen, and therefore oxygen will diffuse into the pulmonary capillaries, return via the pulmonary veins into the heart, left side of the heart, and then via the aorta it will supply different parts of the body. The carbon dioxide which has entered the alveoli, via the act of expiration you will breathe out. And now the gas, as the oxygen has entered the circulation. Now we will talk about ventilation and perfusion. Okay. So what is ventilation? Gas exchange was just inhaling and exhaling, right? Or breathing in oxygen and exhaling carbon dioxide. But ventilation is the amount of air that reaches the alveoli. So it travels through your nose, mouth, through the pharynx, or through the nasopharynx, through the larynx, trachea, primary bronchi, secondary bronchi, tertiary bronchi, bronchioles, and finally the alveolar duct and alveolar sac. So the amount of air that reaches the alveoli is the ventilation. Now there needs to be equilibrium, or the ventilation and perfusion should go hand in hand, because just having air in the alveoli is not enough. What is perfusion? Perfusion is the amount of blood traveling here. So you not only want oxygen here, but you also want the oxygen to enter the capillaries, right? Enter into the circulation, because 98% of the oxygen is traveling via blood with the help of, and it is carried to the tissues with the help of hemoglobin. So we will talk about ventilation perfusion ratio in the next class. See you soon. Have a good day.